Within the automotive market, the explosion of electronics in the last 10 years has been dramatic. We're sitting here today in 2013. If you bought a 2003 model year car, there's practically no electronics in it. There's maybe a radio with a CD player. Look at it today in terms of the functionality required, in terms of all the advanced driver's assistance systems, the connected capability, and then what's happened within the powertrain, all the clean activity that's going on. So it's a very dynamic market.
The challenges the automakers face has to do with the driving range of electric vehicles, which relates to the battery size and cost. And of course, the batteries are very complex objects which need to be monitored for safety and efficiency.
Now, how do you achieve cost reduction in these battery packs? One of the ways is to just increase the level of integration, reduce the number of components which are being used in the battery pack. So we have done very well there. Where the solution in the past used to be, a fairly large PCB, the most recent solutions which are being put together with our ICs are literally maybe 2 inches by 4-inch boards. Okay, so really, we've helped customers shrink the size of the solutions tremendously. In the process, the cost of the battery pack has been, of the electronics in the battery pack has been, I would say, reduced probably by 50% or more.
Cars are becoming more conscious because they have a variety of sensors. Lane departure sensors, backup sensors, rear view cameras to see what's going on behind the car. And in fact, the sensing capabilities and the intelligence of the cars is increasing so much that we are now seeing the advent of autonomous cars.
In the future, what we'll see is cameras around the car. Cameras that can be used for backup, for safety, at the sides of the car for lane warning, lane departure warning. You put some cameras in a car, now you can recognize the driver, you can recognize that the driver's falling asleep and needs some help to avoid an accident. You can recognize that there's a child in the passenger seat, shouldn't be there. You can do a lot of these things. The car just becomes able to do everything itself.
Consumers really want a connected car. They want all the functionality they have on their smartphone or tablet to be present in the vehicle.
The challenges that the automakers face in creating a more connected car is really creating those radio links. Maxim has a lot of technology to offer in this arena, specifically in satellite radio communications and satellite receivers. But in addition to that, it's not only receiving the information from the outside world through these wireless links, but it's also communicating that information within the car. And in order to communicate that information, there's a need for high-speed links within the car. And that's really a very thorny analog mixed signal problem, which is where we excel, where we have the know-how to do it.
The circuit challenges of keeping the speed going up, but at the same time containing the noise is probably one of Maxim's biggest challenges. And we're spending a lot of time on circuit techniques, on IC design techniques, on board design techniques, because ultimately our customers don't just want us to design a chip, they want us to tell them how that chip goes in the board.
It's very exciting because we're helping enable a next generation car. Not only are they clean, conscious, and connected, which has economic benefits, but there's also environmental and sociological benefits that Maxim Integrated is helping bring into the world.